There's no.
Yeah. The average fares for domestic flights here. And we're going to write an equation that will be used to predict airfares. Okay. So we can pick any two of these points. The year is X, the cost is Y. So what 2 years you want to use? Because they're small, or these two? Okay, so this will be X1, Y1, this will be X2, Y2. Okay. First I have to find the slope. Okay, so I have Y2 minus Y1 divided by X2 minus X1. That one's easy. 78 minus 66 is 12, so my slope is 12. Okay. Now I use my slope and any point. What point do we want to use? What year? We'll use 2005. Okay. Now, we say that 366 is equal to 12 times plus b. Here's where it gets tricky. We can either use 5 for 2005 and just say that x is 5 starting from 2000, or we can actually use 2005. If we use just 5, then every time we talk about a year, it has to be like 5, 6, 7, 9, not 2009. If we use 2005, then we'll actually get the full year. So what do we want to do?
Yeah, just use 5.
Okay, so we'll just use 5.
If we want to graph, when we graph it, we're not going to put months or anything. We're just going to put
The year, so
right?
yeah. So we get 306 is equal to b. So the airfare equation is y is equal to 12 x plus 306, where x is the years after, so the number of years after 2000. So I want to put that in there so that we know it's.
And that's the number like step 2.
Yeah, this will be like step 3 or the final step.
Didn't we not have just subtracted?
Hmm?
Just subtracted?
This one?
Did we not just take it and subtracted?
Well, yeah, we did, basically. I just wanted to keep it in the same format so that we're familiar.
Okay.
Okay, in addition to his weekly salary, Ethan is paid $16 per delivery. Last week, he made 5 deliveries and his total pay was $215. Okay, we have to figure out what is this number? Is this $16 per delivery
It's in the x, right?
his slope or his y-intercept? Okay, here's the thing. Okay, we have to figure out his pay.
It goes up $16.
Is equal to salary plus $16 times the deliveries. This is how we're going to figure this out, okay? That's what his pay is, right? His pay is his salary plus $16 times the number of deliveries. What does that kind of look like if we moved it around? Right? So that would make 16M the delivery number X and the salary B and the pay Y. Does that make sense? So we could figure out which number that is using this sort of like figure, you know, by writing it out with words and then figure out what word is which. So I know his per delivery cost. I know his pay. He made 5 deliveries. This is X. This is Y. This is M. know what his salary is. That's what we're trying to find out. What's his salary? So 16 times 5 is going to be 80. Subtract that 80. What is that? 13? Did I do that right? Yeah, 13. Okay. So his salary is $125 or $135. So the equation for his pay is, we're supposed to use T for total pay, is equal to 16 times D plus 135. This of it is to do what's called linear extrapolation, which this occurs in businesses a lot, right? And we use data that you have to create a formula or an equation for that data, and that allows us to make estimates based on information that's outside the data set. So our airplane data went from 2004 to 2007. Here's our equation that we came up with. So I'm going to bring that forward. Was it y equals 12x?
Y equals 12x plus.
Where did the trapezoid come from? I don't even know. Okay, so we're at y equals 12x plus 306. Okay. For this one, x will be 10. And what on earth is this thing doing? And for this one, x will be 20. Because remember we said we're just going to use that part. So in 2010, if our data followed perfectly, we would have $426 for the same flight. And if our data continues in the same pattern, if we go to 2020, the same flight should cost $546.
That's a D.
We're here 10. 10, sorry. Now, this may not be 100% accurate because it's extrapolation, it's best guesstimates. They're not, we can't come back in 2020 and be like, oh, you were wrong. The flight was only 490. These are just, it's to make estimates.